Okay, here we're going to do the second part of the 11.5 lecture. And again, we're just solving these equations with radicals in them. And if you remember from last time, we had to get the radical on one side by itself, and then everything else to the other side. And if there's two radicals, that just means we have to do everything twice. And so since this one is already set up where we have a radical on one side and everything else here, I'm just going to say, well, let's square that side and let's square that side. So when we square the left here, we just get 2x plus 2. Now when we square this, 3 squared is 9, plus 2 times 3 times that is going to give us 6 square root of 2x minus 1. And when we square this, we just get 2x minus 1. All right, so now what we have is 9 minus 1 is 8. So if I want to take it to the other side, I'll subtract 8. And here I'll subtract 2x. And so here, 2x minus 2x is 0. 2 minus 8 is minus 6. And on the right, we get 6 square root of 2x minus 1. All right. So now what we have to do is continue on simplifying this. And I'm thinking, and this is looking like the last problem in the first lecture. And when we square both sides here, we get 36. And then that equals, and here we have 36 and then times 2x minus 1. And so 36 equals, here we have 72x, and then we have minus 36. So we're going to add 36. We're going to add 36. And so 72 equals 72x. And so all we have to do, like last time, is just divide, and we get x equals 1. All right, now let's see what we get for if that's the true solution. So what we do is we verify. So we plug back in. So 2 times 1 is 2 plus 2. And that says equals 3 plus square root of 2 times 2 is 4. And then we have minus 1. And, oh, that's a 1, not a 2. Sorry. So we better erase this, otherwise we're not going to get the right answer. So it's 2 times 1 is 2 minus 1. And so here we have the square root of 6 equals 3 plus, here we have square root of 1. And so this one we get on the right 4, and 4 squared would be 16. We don't have 16 here, so the square root of 6 does not equal 4. Okay, so that means that's not a solution, and there is no solution to this one. Okay, and again, that's why we check these to make sure if any of them are true or not, and this one it's not. What about this one? Well, this is back to one where we actually have to take the 1 square root to the other side. So we're going to add the square root of 3x plus 6, add the square root of 3x plus 6. And so when we do that, we get the square root of 7x plus 2 equals 6 plus the square root of 3x plus 6. So basically, we've just added it to both sides. Now we get to square both sides. Okay, now when you square a square root, you just get what's underneath it, so 7x plus 2. And now we square this, so 6 squared is 36 plus, now we take 2 times 6 times that, so it's going to be 12 square root 3x plus 6 plus, and then when you square this, we just get 3x plus 6. All right, so what do we have now? So 36 plus 6 is going to be 42, so let's subtract 42. And then let's subtract 3x. And so 7 minus 3 is 4x. 2 minus 42 is minus 40. And that equals, and then it looks like 12 square root of 3x plus 6. Okay. So it looks like these numbers are going to get quite large when we start squaring, you know, this and that. So let's go ahead and multiply that and that. So what we have here, where did the squared go? And so 4x squared is going to give me 16x squared. And then I'll have 2 times that, so it's going to be 4 times 40. That's 160 times 2 is 320, so it's a negative 320x. And 40 times 40, that's going to give me plus 1600, it looks like. And that equals 12 squared is 144 times 3x plus 6. All right, so now what do we have? Well, let's go ahead and just bring this down on the left. And now 144 times 3 is going to be 12, 13, looks like 432x. And then doubling that, that's going to give us 864. So that's going to be plus 864. Now we're going to get all on the left side. So minus 432 minus 864. So we get all that equal to 0. So we have 16x squared. And then we have minus 752x. And then we borrow. That's going to give us a 6. And then that's going to be a 3. And then that's going to be a 7. And it's going to be a positive. All right. Now we have to kind of think about what we can do. So what I'm going to do is I'm going to show on my other screen my calculator. And so we had 736. And let's see if that's divisible by 16. So that one is. What about 752? That's divisible by 16 as well. And so that means I can take and multiply everything by 1 over 16 to simplify the factoring. So that's going to give me x squared, and I believe that was minus 47x, and then plus 46 equals 0. Well, here I have x and x. They're both going to be negative. And 2 factors of 46 to add to 47 would be 46 and 1. So that made it a lot simpler than trying to factor this here. And so now when I do that, then I get x minus 46 equals 0 and x minus 1 equals 0. So x is equal to either 46 or x is equal to 1. Okay. Well, when we do this, we're going to have the square root of 7 times 46 plus 2, and then minus, that's the square root of 3 times 46 plus 6, and that's equal to 6. Well, let's go ahead and do that on the calculator because I'm not going to do that in my head. And so we had the square root of, we had 7 times 46 plus 2, and then we had minus, we had the square root of, and then it was 3 times 46, and then plus 6 out of that, and that was supposed to equal 6, and it does. So that one worked. Now I'm going to cheat, and I'm going to do second enter, and I'm just going to change my value. So the other one was equal to a 1. So I'll put a 1 in here, delete that. Plug a 1 in here, delete that, and that's supposed to equal 6 as well. That equals 0, so that one doesn't work. And so so this one does work by calculator, and then the one we did 7 times 1 plus 2, then minus the square root of 3 times 1 plus 6 equals 6. That one didn't work, and so we can say yay and nay. Okay, and so these are kind of ones where plugging in your calculator might be the point where you actually have to start doing that a little more often when you get these larger numbers. Okay. Well, I guess we're back to another one with 2 square roots. So guess what? We'll just add the square root to both sides. And what do we get there? Well, we get the square root of 2 minus 3x equals 3 plus the square root of 3x plus 7. And we do as we always do, we square both sides. So when we square that, we get 2 minus 3x. And here we square 3, that's 9. Then 2 times 3 times that's going to be 6 square root of 3x plus 7. And when we square that, that's just 3x plus 7. So now we have 9 plus 7, so that's 16. And so we subtract 16. And here, let's subtract 3x. All right, so 2 minus 16, that's going to give me minus 14, and then that's going to be minus 6x, and that gives me a 6 square root of 3x plus 7. Now I get to square both of those. All right, so 14 times 14 is 196, so that's positive. And then 2 times 14 times 6, that's 12 times that. So that's going to be plus 168x, and that's going to be plus 36x squared. And then we have 6 squared, so that's 36 times 3x plus 7. And so if we write this in decreasing order, that's 30, well, let's make that a nicer 36. 36x squared plus 168x plus 196 equals, okay, now 36 times 3, so that's 318, 108x plus, and then 7, that's going to be 42, that's 25. So subtract 108x, subtract 108x, subtract 252, oops, 52. So everything on the right's gone, and then we have 36x squared, and then it looks like we have plus 60x still, because the 1s and 8s cancel, we have 6. And then 252, that looks like it's going to be a minus, and then that's going to be a 56, I believe. All right, so what do those all have in common? 36 is 4 times 9, that could be 4 times 15, and 4 and 14. Okay, so let's take and divide everything by 4. So we'll multiply everything by a fourth. And let's see what that gives us. 9x squared plus 15x, and then that was minus 14 equals 0. All right, so since these are so close and we have that, I think we'll have to break that probably into 3x and 3x, and we'll probably do a 2 and a 7. I don't know which way it matters here. So that's going to be 21 and 6. So if we take plus 21 minus 6, that'll give us the 15, and that gives us a minus 14. So 3x minus 2 equals 0, and 3x plus 7 equals 0. So x equals 2/3. Here x is equal to a negative 7/3. All right, so here we'll have the square root of 2 minus 3 times 2/3. And then we have minus square root of 3 times 2/3 plus 7, and that's equal to 3. Well, that cancels that, and 2 minus 2 is 0. Here, that cancels that, and 7 plus 2 is 9. Square root of that's going to be, so it's a negative 3 equals 3. Well, that one doesn't work. So 2/3 is out. What about 7/3? Well, it's going to be similar. 2 minus 3 times 7/3, and it's negative. And then here we have minus square root of 3 times negative 7/3. And then we have plus 7 equals 3. And so here we have 3 cancels 3. And a minus is plus, so 7 plus 2 is 9. So square root of that's 3 minus. Now cancel that. We have minus 7 plus 7 is 0. So that, oops, that's equal to 3, not that. And that's equal to 3. That one works. And so then our solution is negative 7/3. Okay? All right. Now we have a couple application problems. So with these, what we have to do is read what it's asking, plug in things, and most likely we're going to use our calculator again. So here it says a person's BMI is a measure of body fat based on height and weight. If a person's BMI is above 25 and below 30, he or she is classified as overweight. A person's height in terms of his or her weight is in pounds. The W And body mass index B is given by the following equation here. HW is equal to the square root of 703W over B. Okay. So it says, how tall will a person be if he or she weighs 225 pounds, okay, and has a BMI of 25, and we want to round our answer to just the one decimal place. So height is going to be based on our weight of 225 pounds. So you have h of 225 equals square root of 703 times 225 all over our BMI, which we said was 25. Okay, so if we go back to our calculator, let's clear this off so we can start from scratch. We want to take the square root of, and now we're going to take 703 times 225 divided by our BMI, which they said was 25, and so 79.54, and they want it to one decimal place, so this is going to be 79.5, and we are in this case it says it's in inches. Okay, so that would be what we'd have to do here. So we had to know, we had to plug in our weight here, plug our weight here, plug our BMI here, and we get our height out in inches. Okay, so that's part A. What does part B ask for? Well, this one it says, well, okay, now we know they're 64 inches tall and we have a BMI of 25, so we want to know what is the weight. Okay, well, what we have to do is just plug everything in that we know. So we know the weight, which is 64, and that's equal to, and then we have the square root of, now that was 703. Now we don't know the W, and we know the BMI again is 25. So this is an equation. And so how do we get rid of the square root? Well, guess what? We square that side and we square that side. So what we need to do is to get rid of this on the right, we have 703W divided by 25, and on the other side we have 64 squared. So I'm just going to leave that as that. And so then I'm going to multiply by 25 over 703 on both sides, because then it will cancel and I'll get W. So I'll multiply by 25 over 703. And so W is equal to this here. So let's go back and see what that looks like on our calculator. And so what we have was the 25 times, it was 64 squared, and then we had the divided by, and that was the 703. And so our weight was 145.66. So let's see what they asked for, how many decimal places. One decimal place, so it was 145.66, so that would round up to 7, and that would be in pounds. And so that would be our weight, okay? All right, what about this one? So this one, it says the time to take for a pendulum to swing back and forth one time can be represented by the function s of x equals 2 pi times the square root of x over 32, where s of x is the time in seconds, so this is going to be in seconds, and x is the length of pendulum in feet. Okay, so it says how many seconds will it take for a 5-foot pendulum to swing back and forth one time round to one decimal place? So we want s of 5 equals 2 pi times the square root of 5 over 32. Okay, well, that's pretty easy. We just plug that in our calculator again. So we're going to have 2, and then we'll have pi, and we'll have square root of, and that was 5 divided by 32, and that should give us the value, and we get 2.48. And they want it to one decimal place, so this is equal to 2.5, and it's in seconds. And so s of 5 is equal to 2.5 seconds. Okay, so again, plugging in, simplifying, and using your calculator, and all of that's pretty easy. What about B? Well, now it says if it takes 2 seconds for a pendulum to swing back and forth, what is the length of pendulum? Okay, well, we have s of x is going to be 2, and so that's going to be equal to 2 pi square root of, and on the right side we have x, we don't know that one, and it was over 32, if I remember right. Yeah. All right. So how are we going to do this? Well, I'm going to divide by 2 pi. And I'm going to divide by 2 pi. So that gives me 1 over pi is equal to square root of x over 32. Okay. Well, now what do? Well, we square both sides. And so when we do that, we get x over 32 equals 1 over pi squared. Multiply by 32, multiply by 32. So x is equal to 32 over pi squared. So 32 divided by pi squared. So it says 3.24, and we're rounding to one decimal place, so it is equal to 3.2, and this is going to be in feet. So the pendulum length is 3.2 feet. All right, so that's all I have for this section. Hopefully that will help you.